Hey guys, it's Dr. Williams, and in this video, we're going to practice mole to mass and mass to mole conversions. You wanted a lot of practice, so here it is. But first, we're going to review molar mass, how to calculate and determine molar mass, because you have to do that for every one of these problems. So to calculate the molar mass for these elements, we first have to look at A, the mass of each element that's in the compound from the periodic table, and B, how many of each of those elements we have in the compound. So let's start with sodium chloride. The first thing I'm going to do is count the number of each type of atom, make a tally sheet. I have sodium, 1, and I have chlorine, 1. If I go to my periodic table, that's going to be 1 times the mass of sodium, which is 22.990, and chlorine, I have a mass of 35.45. If you're using ptable.com and not familiar with where to find the atomic mass, it is going to be the number under the chemical name. For instance, with chlorine, you will see the name chlorine written out, and then underneath that, you will find 35.45. It's going to be a number that has decimals or parentheses around it. Now, once we determine each of the elements and have determined the mass, we want to determine the total mass of that element in that compound. So since we have one sodium times 22.990, 1 times 22.990 is 22.990. 1 times 35.45 is 35.45. Now you want to add these together, and that gives us 58.44 grams per mole. I am not rounding to significant figures because I want all of the as much information as I can get when I'm using my calculations in the next part. So I'm not going to be rounding molar mass to sig figs. If you're doing this just as a molar mass worksheet, check with your teacher to see if you need to look at sig figs. So for our next one, we have hydrogen, phosphorus, and oxygen. I have 3 hydrogens, I have 1 phosphorus, and I have 3 oxygens. So let's go to the periodic table, draw a line to make sure I can separate these. So we have 1.008 is our atomic mass, our average weighted atomic mass for hydrogen. For phosphorus, it is 30.974. And for oxygen, we have 15.999. Now I'm going to complete the calculations to determine the mass of hydrogen in this molecule. 3 times 1.008 gives me 3.024 grams per mole. This will 1 times 30.974 is 30.974 grams per mole. And 3 times 15.999 gives me 47.997 grams per mole. The last thing I want to do is add all 3 of these up to find the total mass per mole for this molecule. 81.995 grams per mole. Since this next one is going to require quite a bit of room, I am going to write the answer to the side and then delete this part so that I can make more room. Now, the next one, first, I'm going to just go ahead and tally all of the elements that I have here. I have nitrogen, hydrogen, sulfur, and oxygen. So to determine how many nitrogens I have in this compound, I need to distribute what's outside of the ammonium polyatomic ion to each element inside. So 2 times a subscript of 1 by the nitrogen means that I have 2 nitrogens. The 2 will be multiplied by the 4 subscript by the hydrogen, which means I have 8. 2 times 4 is 8, so I have 8 hydrogens. I have 1 sulfur and I have 4 oxygens. Now I'm going to use a periodic table to find out the mass for each individual. Each nitrogen, oops, each nitrogen is 14.007 grams per mole. Each hydrogen is 1.008. Sulfur is 32.06 and oxygen is 15.999. So now we multiply out each line individually so that we can determine the total mass of that element in the compound. 2 nitrogens at 14.07 gives us 28.014 grams per mole. We have 8.064 grams per mole of hydrogen. 1 sulfur gives us 32.06 grams per mole. And 4 oxygens will give us 63.996 grams per mole. Add all these together. The mass per mole for this molecule is 132.134 grams per mole. Let me know if you want more molar mass practice than what is in your tutoring accounts. So let's take what we have learned or reviewed with molar mass and apply it to grams to mole and moles to gram conversions. We always start with what is given and then set that up to convert to what we want or what they're asking for. And we're going to use molar mass as our conversion factor. Remember, a conversion factor is whatever you're using to convert from one amount or type of substance to another. So our first question is how many grams are in 78 moles of calcium? Our known is 78 moles of calcium. And our unknown, which is what we want to find out or the problem is asking us to solve for, is the number of grams of calcium. Now, since we're not converting calcium to a different substance, such as calcium oxide or calcium chloride, we do not need to use mole ratio. But what we do need is the molar mass of calcium. And since calcium is by itself, the atomic mass that's listed on a periodic table is the mass per 1 mole of calcium. So calcium has a molar mass of 40.078 grams per mole. Now we can write this in 2 ways. We can write 40.078 grams over 1 mole, or we can write 1 mole over 40.078 grams. This is important because we're going to use this as conversion factors. So let's see how this looks in a problem. We are given 78 moles of calcium. We always begin with what we're given. And we want to do something to that to convert that to grams of calcium. because that is what we want. So we want to cancel out moles and leave grams. In order to cancel out moles, moles would have to be on the bottom of our conversion factor and grams will need to be on top. So then that will match this conversion factor. So we will put 40.078 grams at the top since we want the units for grams to remain and we want to cancel out the calcium moles. Next, we're going to multiply across, which is 78 times 40.078 and divide by 1. This is per 1 mole. And our full answer is 3,126.084 grams of calcium. Since for sig figs, we have only two significant figures, so this would be 3.1 times 10, 1, 2, 3, the third grams of calcium. Let's work another one. How many grams are in 3.8 moles of chlorine? Our known is 3.8 moles of chlorine, and our unknown, we want to find out how many grams of chlorine 3 point, are in 3.8 moles. So what would be the molar mass of chlorine? Since chlorine is a single element, is not combined with anything else, then its mass on the periodic table is its molar mass. So the molar mass of chlorine, let's write that better. There we go. Is equal to 35.45 grams per mole. Now that we have our molar mass, we can go ahead and set up our question. We're going to start with our known, which is 3.8 moles of chlorine. We're going to do something with it here in order to get grams of chlorine. So we want to cancel out moles. I'm going to go ahead and set up my molar mass for this conversion. Moles will be at the bottom, grams will be at the top since that's what I want to keep. And the number is always attached to the grams. So now let's do the math. 3.8 times 35.45, and that would give us 134.71 grams of chlorine. Since we have only two sig figs, 3.8 is two sig figs. Remember, we do not include our conversion factors in our sig fig determination, in the determination of the number of sig figs. Those are considered exact numbers, and we do not, are infinite numbers, and we do not consider those when we're looking at sig figs. So since we need two sig figs, we're going to write this in scientific notation, which will be 1.3 times 10 to the 2 grams of chlorine in 3.8 moles of chlorine. Our next example is asking how many moles are in 17 grams of potassium sulfide. So we have a chemical compound. First, let's identify our knowns and our unknowns. Our known is 17 grams of potassium sulfide, and our unknown is how many grams, how many moles is 17 grams of potassium sulfide. So we want to find out the number of moles. Now we need to determine our molar mass. We have potassium and we have sulfide. We have two potassiums and one sulfide. Potassium have a molar mass of 39.098 and sulfur has a mass of 32.06. We're going to take these on across. 2 times 39.098 gives us 78 0.196 grams per mole of potassium in potassium sulfide. And we have 32.06 grams per mole of sulfur in potassium sulfide. If we were to add those two together, then we have a total molar mass for potassium sulfide of 110.256 grams per mole. All right, now to set up our problem. We start with our given, which is 17 grams of potassium sulfide, and we need to set up our conversion to convert from grams to moles of potassium sulfide. We want to get rid of grams, so we're going to put grams at the bottom and moles at the top. Now the number is always attached to the grams. So that means that this time grams will be in the denominator. So we see that grams of potassium sulfide cancel, leaving moles. And completing the math, that would be 17 times 1, because we multiply across the numerators and divide by the denominator. Divided by 110.256, and that gives us 0.1541, and I think I can round to 9 right here. I have enough significant figures to go past 2. So the answer with the correct number of sig figs would be 0.15 moles of potassium sulfide, or in 17 grams of potassium sulfide. For this next one, I would like for you to pause the video, go ahead and solve how many moles are in 13 grams of silicon oxide. Remember to identify your known, your unknown, then calculate your molar mass for silicon oxide, then use that molar mass to set up and solve for the number of moles. We know that we have 13 grams of silicon oxide because that is what they gave to us. Our unknown, or what we're trying to find, is the number of moles that are in 13 grams of silicon oxide. So the next step I want to do is to find the molar mass of silicon oxide. For silicon, I have 1, and if you had problems locating silicon on the periodic table, it is atomic number 14. The mass for silicon is 28.085 grams per mole. Oxygen, I have 2 times 15.999 grams per mole. The more you use the periodic table, the more you will begin to start memorizing almost, or just knowing these values by heart. Because I did not give myself quite enough room, I'm going to write the values for each down here. This is silicon is 28.085 grams per mole, and oxygen times 2 equals 31.998 grams per mole. When I add these two up, we have 60.083 grams per every mole of silicon oxide. Now let's set up our problem. We begin with 13 grams of silicon oxide, and we're going to set this up in a way where we are calculating the moles of silicon oxide. We want to use our molar mass in a way where grams is at the bottom so that we can cancel out grams of silicon oxide and leave moles of silicon oxide. Remember, the number is always attached to the grams. It follows the grams around. This is going to allow us to cancel out grams. And in order to finish up our math, we're going to take 13 times 1 going across the numerators divided by 60.083 gives us 0.216 moles. I wrote one value more than the number of significant figures so that we can round. And if I'm paying attention to significant figures, this would be the number of moles that are in 13 grams of silicon oxide, 0.22 moles. For our last problem, we are asked how many grams are in 0.73 moles of calcium phosphate. Go ahead and pause the video and go through the steps to solve this problem. Starting with our known, we have 0.73 moles of calcium phosphate. And our unknown is that we want to know, or they're asking us, how many grams are in 0.73 moles of calcium phosphate. So now we have to determine our molar mass. We have 3 calciums. We need to distribute this to each of the elements inside the parentheses. So for our phosphorus, we have 1 times 2, or 2 times 1. That will give us 2 phosphorus. And for our oxygen, we have 2 times 3, which will give us 6 oxygens. Calcium, looking at our periodic table, has a molar mass of 40.078 grams per mole for 1 calcium. Phosphorus has a mass of 30.974 grams per mole for 1 phosphorus, and oxygen has a mass of 15.994 grams per mole for each oxygen. Calcium has 20.234 grams per mole in this molecule. Phosphate has 61.948 grams per mole in this molecule. I do apologize. That should be 999. 95.994 grams per mole. So now let's add all of these together, and we have 278.176 grams per mole of calcium phosphate. Now we're going to use the molar mass to figure out the grams in 0.73 moles. We're given 0.73 moles of calcium phosphate. And we're going to convert this into grams of calcium phosphate, right? What we are looking for back here. And we are going to cancel out moles, which means moles will be at the bottom. And we're going to leave grams at the top. And the number always goes with the grams. The mass always goes with the grams. So now we're going to cancel out moles, which leaves grams, and we will multiply across. So that's 0.73 times 278.176, which gives us, and divided by 1, and that gives us 203.06848 grams of calcium phosphate. And because we have two significant figures, we can write this 2.0 times 10 to the second grams of potassium phosphate. As always, thank you guys for watching, and I will see you in our next class.